Today we're going to discuss derivative of inverse trig functions. Derivative of sine x, sine inverse x is equal to 1 over square root of 1 minus x squared. Derivative of tangent inverse x is 1 over 1 plus x squared. Derivative of secant inverse x is 1 over absolute value of x, and then square root of x squared minus 1. Memorize these three. These come very handy, and I'm going to talk about the proofs of these as well. We can use implicit differentiation to do the proofs. So if you remember these three, you actually do remember rest of them as well. Derivative of cosine inverse x would be negative of 1 over square root of 1 minus x squared. Derivative of cotangent x would be negative 1 over 1 plus x squared. Derivative of cosecant x would be negative 1 over absolute value of x square root of x squared minus 1. So memorize these derivative rules for inverse trig functions. To prove them, let's just look at the proof of derivative of sine inverse x, where x lies between negative 1 to 1. We know y, the function y, because we're doing dy dx, so my function y here is the sine inverse x. Y is equal to sine inverse x if and if sine of y is equal to x. That's the inverse function. Sine of y is equal to x. That's how we can say sine inverse x is equal to y. Sine of y is equal to x. Now I'm going to go ahead and do the derivative of sine of y, derivative of sine of y, and derivative of x. So I'm going to do the derivative on both sides. Derivative of sine y would be cos y, and we must take on a dy dx because y is a function of x. Y is a function of x. So I'm going to tack on a dy dx. And derivative of x is equal to 1. Now I'm going to isolate the dy dx, and I would have 1 over cosine y. We can also write cosine y as square root of 1 minus sine square y, because 1 minus sine square y is cos square y, and when we do the square root, we would be able to get the cosine y. So just writing it in a different format, and then we're left with 1 over square root of 1 minus x squared, because sine of y is x. We call that in the beginning, sine of y is x. Okay, and that's one proof. Similarly, we can prove the derivative of cosine x is equal to negative 1 over square root of 1 minus x squared. So we start by y is equal to cos inverse x, cos y is equal to y, and then derivative of cos y is equal to derivative of x. Cos y would be negative sine y dy dx is equal to 1. We get the dy dx by itself, and eventually replace the cosine y by x squared, or cosine y by x. And similarly, for tangent inverse x, we can use actually multiple different proofs here, but we can do implicit differentiation just the way we did now, and continue to the derivative for tangent inverse x. Derivative for secant inverse x turned out to be 1 over x square root of x squared minus 1. Derivative of cotangent inverse x would be negative 1 over 1 plus x squared. Derivative of cosecant x would be negative 1 over absolute value of x square root of x squared minus 1. So memorize all these 6 derivative rules, and we can easily prove them using implicit differentiation. Now also remember about the inverse trig functions, their domains and ranges. For sine of x, domain is negative 1, sine inverse x. So sine inverse x, domain is negative 1 to 1, and the range is negative pi over 2 to positive pi over 2. For cosine inverse x, domain is negative 1 to 1, and the range is 0 to pi. For tangent inverse x, domain is infinity, negative infinity to positive infinity, and range is negative pi over 2 to positive pi over 2. For cotangent inverse x, domain is negative infinity to positive infinity, and the range is 0 to pi. And same for secant inverse x and cosecant inverse x. So memorize these domains and ranges. Okay, now we're going to look at some examples using the rules, finding the derivative of inverse trig functions, and also the chain rule. If I had cos inverse x, then I could just use 1 over square root of 1 minus x squared with the negative in the front. But because I don't have x, I have something more than an x. So it's going to be, we would have to do the chain rule here as well. So derivative of cos inverse x is 1 minus 1 over x squared. In this case, x squared is 3x squared. X is 3x squared. So multiply with the chain rule, which is going to be 6x. Multiply with 6x because of the chain rule. Negative 1 over, no, we can just write negative 6x over 1 minus 9x to the 4th. That is the derivative in this case. derivative of sine of cosine inverse x. Okay, derivative of sine of cosine inverse x. What's the derivative of sine x? It is cosine of that x, in this case the xy. x was cos inverse x, so it turns out to be negative 1 over square root of 1 minus x squared cosine of cos inverse of x. Cosine of cos inverse x. Cosine of cos inverse x. Okay, another example. Here we're going to have to use the quotient rule. For quotient rule, we have cos inverse x over sine inverse x. Okay, so quotient rule says sine inverse x squared, low d high, derivative of higher term, it's going to have a negative in the front, minus high d low. The higher term is cos inverse x, and the derivative of lower term is 1 over 1 minus x squared. A little bit cleaning up in the numerator. I have 1 minus x squared minus cos inverse x over square root of 1 minus x squared over sine inverse x squared. And I'm going to leave it at this point, or we can go ahead and simplify a little more. So this would be negative sine inverse x minus cos inverse x over square root of 1 minus x squared sine inverse x squared. All right, see another example. Y is equal to square root of 1 minus t squared plus sine inverse t. Now y prime is going to be 1 over square root 1 over 2 1 minus t squared times negative 2t plus 1 over 1 minus t squared. So negative 2 and 2 is gone. Negative t over square root of 1 minus t squared plus 1 over square root of 1 minus t squared. We can write it as one fraction, 1 minus t in the numerator. And that would be all for derivative of inverse trig functions. That's all for derivative of inverse trig functions.